Okay, well, let's talk about the fundamental graphing principle just a little bit. This is going to be important for us when we're drawing graphs, and anything that's called a fundamental principle is pretty much guaranteed to be a big deal. So this is a pretty big deal. So when we're thinking about graphs of equations, we're thinking about all of the points that make the equation true. So this is on page 23. So a point xy is on the graph of an equation if and only if x and y satisfy the equation. So this is just a fancy way of saying if we plug in x and y, the equation is true. So we can look at an example real quick here. So maybe if we have, I don't know, y equal, let's do 4x squared minus 1. So if we have this and we want to think about the graph. So maybe the first question we can ask is, I don't know, is the point 3, 1 on the graph? So to answer this, we would have to make sure it satisfies the definition of, well, what it means to be, well, I guess it's not a definition here, it's a fundamental principle. We just have to make sure that these x and y values, this x value here and this y value here, satisfy the equation. That is, they make it true. So really all we're going to do is take this x value and put it here. We're going to take this y value and put it there. So we'll just substitute 1 in for y, and then that 3 in for x. And then I'll make the nice blue around it. Okay, and now we can, we can see on the face of it pretty quickly that this is not true, but we can carry this out, right? So we got 1 on that side. We have 4 times 3 squared, so 3 squared is 9. 9 times 4 is 36, minus 1 is 35, and this is not true. So, no. 3, 1 is not on the graph. So, right, if we're just asking whether or not a point is on the graph, it really is just that simple. We're just going to plug that point in, and well, we're going to see if it makes it a true statement. And if it does, then that point is on the graph, but if it does not, the point is not on the graph. So this, we're not going to be so concerned with whether or not specific points are on the graph. What we're usually going to be concerned with is finding points on the graph, not just confirming that they are. So let's stick with this one here. If we've got that nice equation or relation, we want to know a bunch of points on this graph so we can draw a picture of it. The main idea here is that we're just going to find a whole bunch of them, and we're going to notice a pattern, and then we're going to connect the dots more or less. So what we can do is we can just pick out values out of the air for what this x should be, and we can find corresponding values of y. Usually we'll want to organize ourselves in a nice little chart. So if I put x's here and y's in this column, well, I know that the y is going to be 4x squared minus 1, right? So whatever I choose for x, my y value is going to be 4 times the square of that thing minus 1. And we can maybe add another column here, x, y. So these are going to be our ordered pairs. Okay, so if we just go and just pick your favorite values in here, it doesn't exactly matter. Something that would probably be in your best interest is to pick small numbers or numbers that might work well. If for example, I have a fraction here, I might want to pick values that would clear that fraction out. But you know, there's no fraction here, so we're fairly unrestricted. Why don't we just pick -2, -1, 0, 1, and 2? Those are usually our good buddies, and we can crank those out pretty quickly. So really all we're going to do to find these y values is we're just going to put 4 times whatever that value is, squared minus 1. And we're going to just do the same thing all the way down the line. So I'm just going to write this with this color first, and then get back in there with this other color. So we got our -2, we got our -1, we got a 0, 1, 2. And now we just crank these out, right? So -2 squared, that's 4. 4 times 4 is 16. Minus 1 would be 15. 4 times 1 squared is 4. Minus 1 would be 3. 4 times 0 is 0. Minus 1, is -1. Kind of looks like a weird -1. All right, 4 times 1 is 1. Minus 1 is 3. 4 times 2 squared would be 4 times 4 is 16. Minus 1 is 15. So we have a bunch of ordered pairs now. So we got -2, 15. We got -1, 3. All right, we're just pairing this x value here with this y value all along these rows. So 0 is going to get paired with -1. We are usually used to doing this sort of thing from previous coursework, but we can do it again here. All right, so now if we want to go and draw a graph, we're just going to plot these points on the plane. So we can draw a nice coordinate plane here. We only went out that far. Let's count by threes. Why not? 3, 6, 9, 12, 15. 3, 6, 9, 12, 15. So -2 goes with 15. -1 goes with 3. 0 goes with -1. So it's like there. 1 goes with 3. And 2 goes with 15. So, I mean, we can label these all. I don't want to clutter it up too much, but we can label all of these, right? Oh, I went to the wrong 3. See, I mean, we're counting by threes, and I made the mistake of not labeling these. That's 3, 6, 9, 12, 15. So maybe just to be clear that these points are not on there, we can continue with the green. So we say, all right, I want to connect these dots, and we do, and that's kind of what the general shape looks like. So again, this is an error here. This was there, this was there. So not those 2 points. Well, we've drawn our beautiful graph. And we can repeat this process for pretty much any nice equation we're given. We can just pluck out x values out of the air and then plug in that x and then solve for y. In this case, it was already solved for us, so we didn't really have too much to do.